Good day, viewers. You are welcome to Tindanious Maths and Science tutorials. If this is your first time, kindly like, comment, subscribe to the channel for more interesting videos. I've even created a playlist where you can find all the videos under transformation of functions. We started with vertical transformation already, and we are clear on that. So today we are going to talk about horizontal transformations of functions under certain conditions. What do I mean by the condition? The condition is the inequality given in question. Okay, so it's under vertical transformation where conditions are also given. So we need to adhere strictly to the conditions being given. We have this. So we have f of x is equal to x squared under the condition. This is the condition, okay? 0 less than or equal to 2 less than or equal to, sorry, we have 0 less than or equal to x less than or equal to 2. As a result of that, when you graph it, which is f of x equals x squared, you are going to get this, and this is the original function. If you want explanations to this, can you visit my previous lecture slides on this? That's vertical transformation. Okay, so I have f of x, which is equal to the expression x minus 2 all squared. Don't be confused with this exponent, okay? Just focus on the expression over here. So if I equate the expression to 0, I'll have x is equal to what? Positive 2. So positive 2 simply implies that, or when you have your x, y plane, positive 2 tells you that you need to move to the right. You know that to the right is wrong. We have a set of what? That's positive real values, okay? And we have, this is what? Negative real values. So as far as this is positive, shifting occurs what? To or towards what? The left hand side. Units, 2 units, 2 units to the right, this way. So the graph becomes this. I have okay, so I have it this way. So this is the original graph, 0 then to 2, because the shifting occurs, okay, towards this side. That means this is going to increase by a magnitude of 2. So from 0, then to increase from 0 then to 2. Then from 2 to 4, from 4 to 6, in that what manner. So please, for horizontal transformation, for horizontal transformation, we are going to focus on the x-axis only. Then the vertical axis, okay, everything there remains constant, no effects. So I have my form already there this way. Then instead of me starting from 0 over here, I will not start from 0 again. Why? Because there is a transformation. Do you get it that way? So it has been increased to 2. So instead of 0, I'll not start from 0. No. Then I'll start from what? So from, that's 2. So from 0 then to 2. To the what? To the right hand side. Then I'll shift towards, let's say, to 4 in that regard. So when I graph it, it will simply be this way, something like this. Like this. Nice one. Okay. So when I trace this to touch the curve this way, then let's say 4 also comes here this way. Yeah, as simple as that. So this is the graph for x minus 2 all squared under this inequality. So the third one is this. We have f of x, which is equal to the expression x, we have x plus 2. So f of x is equal to x plus 2 all squared. Just follow the norm. The expression, set it to 0. So I have x plus 2 is equal to 0. So therefore, x becomes what? Negative 2. So negative simply suggests that you move what? To the left. So far as the xy plane is concerned. Pause. So we have x is equal to negative 2. So far as the xy plane is concerned, this is going to be shifted, the graph is going to be shifted to the left by a unit of what? Of 2. So, so this is 2 units to the left. So when you just graph it, I have this way. So I have x-axis here and I have what? My y-axis here. So let's consult the original function, which is the original graph. And this is the original graph. So I have it this way. Alright? So what I'm supposed to do is just focus on the left hand side, okay? This side. So I have 0. So from 0, I'll move to what? I'll move to negative 2. Why negative 2? Because 2 units to the left. So from 0, then I have a negative 2. Then I still have my what? My 4 over here, vertical. As you see, this remains constant. So what are we supposed to do? So you just join the points together. So I have it this way, something like this. Something like this. Yes. This is the graph of this. As simple as that. Let's consider the fourth one. So I have f of x, which is equal to 2x all squared. This way. How are we supposed to do this? Remember, listen to this for first time. Kindly visit my previous lectures so that you can be able to distinguish between the vertical transformation under certain conditions and horizontal transformation under certain conditions. Alright? So whenever you have this, so far as the vertical transformation is concerned, the scale factor for this is what? Is simply 2. But for horizontal transformation, the scale factor is the reciprocal of the coefficient of x. What do I mean by this? What do you see here? You see the number 2, right? So I write 2. And the reciprocal of 2 is what? Is 1 over the number. So 1 over the 2. So this will be what? The scale factor. So this will be, we are doing it horizontal, right? So horizontal compression. Why compression? So horizontal compression by scale factor of what? Of 1 over 2 half. So let's visit the original graph again. So why are we saying vertical compression? Compression simply means what? There's a shrinkage. So it's either horizontal shrinkage or horizontal compression. So here is from 0 then to 2. So the scale factor here is, we said, so from 0 to 2, that means you are going to divide this by half. So half of 2 gives what? 1. So it will just compress it to this way, to what? To something around like this portion. Did you get it that way? That's why I say what we are compressing the graph. So instead of me drawing it from 0 then up to 2, it will be from 0 what? To 1, because what? There is a shrinkage. So let's move to this side to just draw the graph for that. So this becomes I have x-axis, y-axis here. So therefore, here is still my 0, yeah, and here is my 4. So instead of me writing from 0 to 2, I can just say what? This is my 1. Is that not so? Then this takes this from as something like this again. So when I just trace this, it will touch the x-axis at what? At 1, not 2. Then here is what? Is still my 4. As simple as that. And the last one is I have f of x is equal to negative x all squared. If this is your first time, kindly visit my lecture videos on transformation of functions. We have introduction to transformation of functions 1, that's transformation of functions 2, transformation of functions 3 in that regard. Everything is well explained into details. The explanations to all these over there. So we are just trying to apply the concepts. Okay. So when students encounter questions like this, where we have exponents, most students tend to what? Tend to deviate. They are scared by this exponent. But you realize that we are not making use of what? Of the exponent over here. You get it that way. So this is simply reflection. This is simply reflection in the y-axis. When you visit my previous lecture slides, there is explanation to this. So the graph of this becomes this. This is y-axis. This is my x-axis. So let's just say the original graph here. So what you are supposed to do is, because you are reflecting in the y-axis, you just reflect this towards this side, okay? So it's more or less like mirror images. Do you get it that way? So when you do it that way, you realize that positive 2 here becomes negative 2 here. Just reflect this to this side. So I'll just do that. So I have my 0 here, then I have what? My negative or 2. My 4 still remains what? Untouched, constant over here. So we are going to do this. Something like this, Okay, so I have, so let's say here it will be my negative 2, and this is my 4. As simple as that. Viewers, this is the end of the tutorials. So far as Tindanious Math and Science YouTube channel is concerned, we are going to learn a lot. We are going to explore. Bye.